Known the world over as the jump jet, the Harrier captured the public imagination as the world's first operational vertical takeoff and landing warplane. Harriers went to the European Central Front, where they were deployed to blunt any attack by the Warsaw Pact. The Harrier was also readily adopted by the US Marine Corps, who saw it as an ideal means of supporting troops during heliborne and amphibious assaults. It also spawned the Sea Harrier, without which the Falklands War may have ended very differently. Despite their proven capabilities, this first generation of Harriers was hampered by short range and poor warloads. Development on both sides of the Atlantic led to a much more capable Harrier II that addressed many of the problems. This aircraft remains today as the backbone of the close support fleet for both the RAF and the Marine Corps, and has seen much action in recent conflicts. Thanks to continued development, the Harrier II has also blossomed into a true multi-role aircraft, one that can undertake a range of missions that could only be dreamt of when its predecessor entered service. The latest radar-equipped aircraft can operate in the air defense role and for precision attacks against pinpoint targets, while still retaining their proven prowess in the close support role. In terms of dimensions, the Harrier is a diminutive aircraft. This suited its operational role, as it could easily be accommodated aboard carriers and operate from confined spaces in the field. The AV-8B has a narrower wheel track than its predecessors, enabling it to use even smaller roads and taxiways when deployed. Compared to its rivals, the Harrier is smaller, although the later machines can lift much bigger loads than was previously possible. Weight is a big issue for a vertical takeoff and landing aircraft, and has been trimmed in second-generation machines by the extensive use of composites. Due to the portly fuselage, the Harrier is a subsonic aircraft, although Mach 1 can be surpassed in a shallow dive. While this is a disadvantage in air combat, it is of little concern for ground attack operations. The first-generation Harrier had a very small wing. While this gave it a tremendous rate of roll, it impaired sustained maneuvering, further hampering its effectiveness in air combat. The larger wing of the Harrier II makes it more maneuverable in terms of sustained turns, but with reduced roll rate. A technique developed early on by Marine pilots was used in air combat to give the Harrier an edge. Known as vectoring in forward flight, or VIFing, this involved swiveling the nozzles to dramatically increase lift. This could only be performed at the expense of speed, however, but gave the pilots an emergency last-ditch option if being chased. Handling in wing-borne flight was conventional, but special techniques are needed for the transition to jet-borne flight and while in the hover. To transition from wing-borne flight, the pilot decreases the power setting and rotates the nozzles to the full forward position, about 98 degrees. As the aircraft slows down, the pilot gradually increases power to replace the wing lift and moves the nozzles to the 90-degree position. The aircraft comes to the hover. With the aircraft at a standstill, the pilot moves the aircraft up or down by varying power settings and changes attitude using the reaction control system. For a vertical takeoff, the nozzles are set to 90 degrees and the throttle opened fully. As the aircraft lifts off, the pilot gradually rotates the nozzles aft, allowing the aircraft to pick up forward speed as it climbs away. Most takeoffs, however, are performed using a rolling short field technique. The nozzles are rotated down by about 10 degrees, giving an element of lift, but without affecting forward acceleration too much. Second-generation Harrier IIs have a greatly expanded weapons repertoire compared to their predecessors, thanks mainly to the more sophisticated systems and increased stores carriage potential. The baseline aircraft has 6 underwing pylons, of which the inner 4 are plumbed for fuel tanks. The centerline station can also be used for bomb carriage. RAF aircraft also have an additional pylon under each wing, located forward of the outrigger wheels. These pylons can only be used for carrying short-range air-to-air missiles. Both US and UK Harrier IIs were intended to have new gun systems, but the RAF's 25mm ADAM was not fielded on technical grounds. Marine Corps Harriers have a single 25mm GAU-12 equalizer system. This comprises a multi-barreled cannon in a pod mounted to port under the fuselage and 300 rounds of ammunition in a pod to starboard, the two being connected by a linkless feed system. When the gun isn't installed, large strakes are fitted in place of the pods. The Harrier began life armed with free-fall bombs and rocket pods, and they remain important weapon options. Rockets are carried in a variety of pods and come in 2.75-inch or 5-inch versions with a variety of warhead options. Free-fall bombs can be carried on any of the 7 hardpoints, although the largest weapon, the 2,000-pound Mark 84, is restricted to the inner wing pylons. Medium bombs like the Mark 83 or UK 1,000-pounder can also be carried on the middle wing pylons and centerline, while smaller weapons up to 620 pounds, such as the Mark 82, can also be carried on the outer pylons. A range of cluster bombs is also available, although the British BL-755 has been withdrawn. Other free-fall weapon options are the firebomb, better known as napalm, and the fuel-air explosive bomb. For self-defense, the Harrier II employs the AIM-9 Sidewinder. US aircraft carry the missile on the outboard pylons as here, although British Harriers have an extra dedicated pylon. AV-8B Plus aircraft with APG-65 radar can launch the AIM-120 AMRAAM, giving them a true air defense capability. Up to 4 AMRAAMs can be carried on the wing pylons. The key weapon for the Harrier II is the AGM-65 Maverick. This missile provides pinpoint attacks against a variety of battlefield targets such as armor, artillery, and troop posts. There are several versions available, with TV, infrared, or semi-active laser guidance options. For a harder precision kill against larger targets, the Harrier II can use Paveway 2 laser-guided bombs. US aircraft use the 500-pound GBU-12 and 1,000-pound GBU-16. Although slightly less accurate, the GPS-guided JDAM is a cheaper and more reliable option for precision attacks. AV-8Bs typically employ the GBU-32 1,000-pounder and 500-pound GBU-38. British aircraft have adopted the enhanced Paveway and Paveway 4 bombs that combine the standard laser guidance with a GPS backup. They provide the accuracy of a laser bomb, but with the reliability and low possibility of collateral damage of the GPS weapon. Another UK weapon is the MBDA Brimstone missile, a typical load being 12 carried on triple launchers from the center and outboard wing pylons. Based on the American Hellfire missile, Brimstone uses a millimeter-wave radar seeker to image and identify relevant targets on the battlefield. Unlike its predecessor, the second-generation Harrier is now fitted with a wide range of combat systems. Initially, aircraft were fitted with the Hughes angle rate bombing system in the extreme nose. This combined a laser and TV camera to measure slant angle and range to the target. In the night attack Harrier, the nose was reshaped to house a forward-looking infrared system in a fairing. The FLIR presents imagery on the head-up display, augmenting the pilot's night vision goggles. The RAF's Harrier GR7 also has the FLIR mounted above the nose in a similar installation. 3 different radars have been fitted to the Harrier. The first was the Ferranti Blue Fox used by the Sea Harrier Mark I, followed by the Blue Vixen in the Sea Harrier Mark II. The Americans also installed a multi-mode radar in some of their Harriers to create the AV-8B+. The equipment was the APG-65, the same radar as used in the Hornet. As well as taking over the targeting functions of the angle rate bombing system, the APG-65 added many other targeting functions, as well as providing a meaningful air defense capability. Harrier IIs were fitted with a radar warning set from the start, American aircraft having the ALR-67 system and provision for an ALQ-164 podded jammer carried on the centerline. RAF machines were fitted with the Marconi Zeus, which combined warning receivers with internal jammers. A missile approach warning system is also installed. The Zeus installation adds 2 small prongs that project from the nose. Defences were further enhanced by the adoption of chaff dispensers for British aircraft. Initially, the FIMAT chaff pod was carried on the outer rail, but later ball dispensers were adopted, incorporated into the Sidewinder launch rail. Marine Corps Harriers were initially fitted with flare dispensers under the rear fuselage. More recently, they have adopted upward-firing flare dispensers added either side of the dorsal fin strake. Flares are released during and after low-level attack runs to decoy shoulder-launched missiles away from the aircraft. Another recent addition to the Harrier II is self-designation laser bombing capability through the tiled pod for the RAF and the Lightning for US aircraft. The latter is now routinely used by Marine Harriers operating over Iraq and Afghanistan, carried on the starboard inner pylon. RAF Harriers, both old and new, have also carried various centerline reconnaissance pods, as seen on this GR Mark 7. Whereas the cockpit of the original Harrier was typical of a 1960s fighter, that of the second-generation Harrier II has been dramatically improved to the point where it could be considered modern. The pilot sits on a 0-0 ejection seat. In the RAF aircraft, it is a Martin Baker Mark 12, while US aircraft like this one have a stencil seat. The cockpit is based closely on that of the FA-18 Hornet. There is a wide-angle head-up display for showing relevant flight and targeting information, and also for showing infrared imagery in the night attack aircraft. The cockpit is compatible with night vision goggles. Below the HUD is an up-front controller for entering data into the system. Either side are 2 large Kaiser screens for displaying a wealth of information. The right-hand screen is often used to present a moving map display, something that earlier US aircraft lacked. Above the right-hand screen is a panel showing the status of the nozzle and propulsion system. And to the right is a slim panel with controls for the defensive electronic suite. Below the screen is a fuel control panel. There are 2 angled panels with hydraulic system controls and warning lights. Behind that, the right side console has various secondary aircraft and avionics switches. Immediately below the upfront controller is a small panel for controlling HUD functions, including a video recording function. Below that are the principal flight instruments, comprising airspeed indicator, attitude indicator, radar altimeter, vertical speed indicator, and barometric altimeter. Further switches for systems such as the INS and a trim system status display are located on a panel behind the stick. The stick itself, like the throttle, has numerous buttons to allow full hands-on throttle and stick operation of the major combat systems and displays. On the left side of the main instrument panel, there is a master warning light panel above the display screen, and master arm switch to the left of it. Immediately below is the armament control panel. The main angled side panel has the controls for the undercarriage, flaps, and emergency stores jettison. The side console forward of the throttle has switches for the trim system and for the stability augmentation and attitude hold system. The throttle quadrant is located outboard. Inboard is the nozzle angle control lever with graduated angle markings. With the lever fully forward, the nozzles are pointing aft. An important feature just outside the cockpit is the yaw vane that provides the pilot with a visual cue of wind direction when in the hover. In the two-seater, there are two vanes, with one mounted on top of the canopy for the instructor in the rear cockpit. At the heart of the Harrier's vertical takeoff and landing capability is the Pegasus engine. The first version was bench-tested at Bristol's Patchway facility in September 1959. Half a century later, the engine has evolved considerably in thrust and reliability, but still relies on the same principles as the original. Known to the Americans as the F402 and today a Rolls-Royce product, the Pegasus itself is a two-spool turbofan with a large three-stage fan at the front end. The large intakes allow the Harrier to ingest sufficient air for maximum thrust at zero airspeed, augmented by a ring of auxiliary suck-in doors around each intake. The engine also has water boosting to increase power for the hover. Cold air from the fan is directed into the two front nozzles, while air that has passed through the hot core of the engine is ducted through the rear nozzles. The nozzles themselves are actually built as part of the airframe for extra rigidity. They incorporate vanes to help direct the air. In forward flight, the nozzles point directly aft to provide conventional thrust. To transition to hovering flight, the nozzles are rotated downwards under control of the pilot. They are interlinked so that they are always at the same angle relative to each other. For vertical flight, the nozzles rotate to 90 degrees from the vertical, so that the engine is producing 4 equal columns of lift. The nozzles can rotate past the vertical to give an element of braking when coming to the hover and allow the Harrier to fly backwards. When hovering close to the ground, the Harrier experiences what is called recirculation. This means that thrust from the nozzles bounces back up from the ground under the aircraft. In recirculated air, the cold thrust from the front nozzles provides a barrier to prevent hot air from the rear nozzles being ingested back into the engine, which could lead to a loss of power. Precious lift can be recovered from recirculating air. A cross-dam is lowered between the gun pods or fuselage strakes, and the rear air brake is lowered. Together they form an open box that traps the upward-moving air, extracting important extra lift. Control of the aircraft in the hover is undertaken using a series of reaction control valves, or puffers. High-pressure air is ducted to the extremities of the aircraft to the shuttered valves, which are opened and closed to provide control. Pitch control is handled by puffers under the nose and under the tail cone, while yaw control is provided by puffers either side of the tail. Further valves under the wingtips provide roll control. This system is controlled by the stick, and the puffers are interconnected with the standard flight controls. When the Harrier is maneuvering while hovering, the aerodynamic control surfaces can be seen moving even though they are having little effect on the aircraft. Aerodynamic control surfaces are conventional, comprising a single-piece rudder, all moving tailplanes, and outboard ailerons, which droop slightly for extra lift at low speed. The inboard wing sections mount slotted flaps that provide extra aerodynamic lift at low speed and also capture some recirculated air when hovering. The bicycle undercarriage is another unusual feature of the Harrier. The forward main wheel retracts forward into a bay beneath the cockpit, while the rear main wheel assembly, which takes most of the stress of vertical landing, retracts back into the rear fuselage. This is possible because the Harrier does not have a jet pipe like a conventional jet. Outrigger wheels deploy down from the outer wings to provide stability. Fuel tanks are crammed in around the engine, consisting of a forward fuselage tank, a large tank in the interspar area in the wing, including the center section, and in the upper rear fuselage just behind the wing. The weight has to be concentrated around the center of the aircraft, as it has fine center of gravity limits. On internal fuel alone, the Harrier has a short combat radius, so external tanks are carried from the inner wing pylons for most missions. For refueling in flight, second-generation aircraft have a semi-permanent retractable refueling probe that is fitted to the upper side of the port intake. This allows the Harrier to refuel from drogue-equipped tankers. First-generation Harriers and Sea Harriers served with the Royal Air Force, including service in the Falklands, and the Royal Navy, which operated the Sea Harrier until 2006. In the US, the type served as the AV-8A with the Marine Corps and was used by NASA for various research duties. Early Harriers also served with the Spanish Navy and Royal Thai Navy, and Sea Harriers still fly with the Indian Navy. In the mid-1980s, Harrier IIs began to be delivered. The first Marine Corps squadron was commissioned in 1985, and a total of 9 Harrier II squadrons was formed, including the 4 original Marine units. They were split between Cherry Point on the east coast and Yuma in Arizona, with the squadron forward deployed at Iwakuni in Japan. For the RAF, the second-generation Harrier era began in 1988, when No. 1 Squadron at Wittering began to re-equip with the GR Mark V. Further deliveries went to Numbers 3 and 4 Squadrons in Germany, and the training unit in the UK, which became No. 20 Reserve Squadron. An operational evaluation unit was also established to undertake trials work. The night attack Harrier GR Mark 7 superseded the earlier aircraft from 1990 and soon equipped all three frontline units, including No. 1 Squadron, seen here. Among other taskings, this unit was tasked with reinforcing NATO's northern flank and regularly trained in Norway. The OCU retained GR Mark 5s for some time. It also operated a few elderly T Mark 4s into the mid-1990s to cover the trainer gap, while the unit waited for the second generation T Mark 10 to be delivered. Spain also acquired Harrier IIs. In 1987, day attack AV-8Bs arrived to supplant its first generation aircraft and to serve from the new light carrier Príncipe de Asturias. They were later upgraded to AV-8B Plus standard with radar. Italy joined the ranks of Harrier operators in 1989 when it acquired two TAV-8Bs to begin the training of pilots in anticipation of receiving 16 AV-8B Pluses. Shore-based at Taranto, the Harriers regularly deploy aboard the carrier Giuseppe Garibaldi. US Harriers received their baptism of fire in the 1991 Gulf War, a large force being amassed at the King Abdulaziz Air Base at Al Jubail in Saudi Arabia. From there, they attacked targets mainly in Kuwait, softening up the defenses for the impending marine assault. They were also involved in repelling the Iraqi incursion at Khafji. During the brief land war, they flew intensively to support the marine thrust into Kuwait. Subsequently, Harriers from both the US and UK became embroiled in the Balkans conflict, with RAF Harriers taking part in the 1999 Allied Force operation, concentrating on efforts in Kosovo while flying from shore bases in Italy. Following the 9/11 attacks, Marine Harriers went into action in Afghanistan. Marine and RAF Harriers were also heavily involved in the 2003 Iraq campaign. In recent years, RAF Harrier GR Mark 7s have been regularly deployed aboard Royal Navy carriers, often alongside Sea Harriers. RAF crews have become used to life at sea, honing their bombing skills by attacking splash targets towed behind the carrier. As part of a major reorganization, the Royal Navy's Sea Harrier fleet was withdrawn in April 2006, leaving the GR7 as the UK's only ship-deployable aircraft. The force is now divided between two Air Force and two Navy squadrons, operating as part of the combined Joint Force Harrier. Like their US Marine counterparts, they will fly Harriers until the F-35C Joint Strike Fighter is delivered. The unique attributes of a Harrier opened up many possibilities for the application of air power. For land operations, it meant that the aircraft was no longer tied to fixed, vulnerable airfields, while at sea, it was no longer tied to large and prohibitively costly aircraft carriers. Of course, the Harrier can operate in the same way as any other aircraft. In recent conflicts, field operations have been of little significance, and Harriers have usually operated from conventional airfields. Nevertheless, despite its increased sophistication, the second-generation Harrier can still undertake field operations, and they are still practiced as a matter of routine. Although it can and does use vertical takeoff, the Harrier is better described as a short takeoff and landing or STOVL aircraft, as it can't lift much when taking off vertically. For operations in the field, all that is needed is a short strip of runway and a suitable dispersal area. Today's main Harrier operators, the Royal Air Force and US Marine Corps, employ their aircraft from both ship and shore. Marine Harriers are deployed aboard the US Navy's assault carriers, which also carry large numbers of troop-carrying and gunship helicopters. A typical Marine Expeditionary Unit has 6 Harriers, although greater numbers can be carried for operations that might require more air cover. The US Marine Corps has established a set of operating procedures for the AV-8 that allow it to coordinate carrier operations with helicopters. The standard recovery procedure is for the AV-8 to approach the carrier from the front on a downwind leg and then turn in towards the carrier, decelerating and descending as it turns. The Harrier arrives at the hover off the vessel's port beam. When cleared to land, the Harrier crabs sideways over the deck before settling onto its chosen landing spot. The aircraft then taxis away quickly to clear the landing spot for the next aircraft. In classic assault operations, the Harriers are first used to soften up the intended landing zone prior to the assault. As the Marines move ashore by helicopter, landing craft or hovercraft, the Harriers maintain a high tempo of operations from the assault carrier. Working closely with helicopter gunships, they fly repeated missions over the landing zone to provide an aerial umbrella for the ground forces as they secure a beachhead. Once a solid foothold with a secure perimeter has been established, a shore base can be set up for the Harriers, allowing them to operate much closer to the troops they are supporting. Basing aircraft close to the troops means greater sortie generation, as the aircraft spend less time in transit to where they are needed. The shore base requires a suitable stretch of hard surface from which the Harriers can take off, and an area where they can be parked and serviced. Camouflage netting is often used to hide the aircraft when they are at their dispersals. All the necessary equipment for tactical operations is portable, and a fully operational base can be established ashore with great rapidity. Pilots plan their missions using a portable computer. The data is then loaded onto a cartridge for transfer to the aircraft's computer system. Ground crew work at high intensity to prepare the aircraft for the mission. Loading weapons that have been moved ashore by heavy-lift helicopters. Once airborne, the pilots waste no time in getting to the battle area to support the Marines as they advance from the beachhead. Although the Harrier has precision attack capability, in the close support role, bombs, rockets and guns still have a part to play. The Harriers work closely with forward airborne controllers to lay down accurate weapons and to avoid friendly fire incidents. With weapons expended, the Harriers return to the base to rearm and refuel. The aircraft is designed to be turned around swiftly so that they can be back to the battle zone as quickly as possible. Royal Air Force Harriers practice a similar style of high-intensity field operations stemming from the aircraft's Cold War role in West Germany. The RAF became acknowledged masters of dispersed operations, flying Harriers from short stretches of highway and hiding the aircraft in the woods. The RAF also took its low-level flying expertise to a new high with the Harrier, practicing the art of delivering a range of weaponry from ultra-low level. The service devised and trained in multi-axis attack techniques with minimum time intervals between aircraft to maximize surprise and reduce vulnerability. The idea of freeing the jet fighter from the shackles of conventional airfields was an attractive one and occupied much research time and money in the 1950s. In Britain, the Bristol Engine Company was developing potential power plants and by the end of the decade was running an engine that it called the Pegasus. Early trials were conducted into hovering and controllability using the thrust measuring rig, or flying bedstead as it was popularly known. In October 1960, trials began with an experimental aircraft, the Hawker P-1127. Hover trials led to transitions between jet-borne and wing-borne flight. Based on these tests, Hawker was instructed to develop a militarized version of the P-1127, which was built as the Kestrel FGA Mark I. From the Kestrel was developed the Harrier, the world's first operational vertical takeoff and landing aircraft. The first generation of Harriers enjoyed a successful career. During the Falklands War, Harriers and Sea Harriers, like this aircraft, provided the United Kingdom with all its tactical air power. Despite their success, the early Harriers were nevertheless short on range and weapon load. A dramatic overhaul of the design would go some way to addressing the shortfalls, resulting in an aircraft known to the Americans as the AV-8B and to the British as the Harrier GR Mark V. By the late 1970s, McDonnell Douglas, which later became part of Boeing, was working on an aircraft with an improved Pegasus, a bigger wing with 6 pylons, leading-edge root extensions, a new cockpit, and a bulged canopy giving the pilot a much better view. The new wing was tested on a pair of converted AV-8As in 1978, while a full prototype of the new AV-8B flew in November 1981. By this time, British Aerospace was a partner in the program. The original Harrier established a classic shape that is still evident today in the latest aircraft, a shape driven by the tough demands of vertical flight. The fuselage was necessarily fat to accommodate the large fan section of the Pegasus. Huge intakes were needed as the engine had to operate at maximum thrust while at rest. The wing had to be mounted high to stay out of the way of the nozzles and was angled downwards to improve roll rate and to increase lift from recirculated air. The wing was built as one section, including the center saddle across the aircraft's back. The wing has to be lifted on a crane for full access to the engine. Although a cumbersome operation, it can be conducted in the field with a rudimentary shear legs crane. With the high wing and engine position, a bicycle undercarriage was adopted. A long tail sting was needed to mount the reaction control valves for hover maneuvering. AV-8Bs for the Marine Corps were initially delivered in the day attack configuration. This had an angle rate bombing system mounted in the nose. Harrier GR Mark Vs for the RAF also had ARBS, but additionally had a bulge under the nose for a reconnaissance system that was, in the event, never fitted. In the late 1980s, extensive trials were undertaken using forward-looking infrared as a navigation and targeting aid. This work led to the Harrier GR Mark VII for the RAF, with a sensor mounted above the nose and antennas for its internal ECM system either side of the ARBS. The equivalent version for the Marine Corps became the Night Attack AV-8B. It also had the FLIR mounted in a neat fairing above the nose. Night Attack Harriers greatly increased the type's combat potential. The Marines then went even further by fitting some of their aircraft with APG-65 radar to create the AV-8B Harrier II+. They retained the night attack equipment, and today the Marine fleet is a mix of radar and non-radar machines, all with night capability. McDonnell Douglas also schemed a new two-seater known as the AV-8B, which first flew in October 1986. The RAF also acquired a second-generation two-seater in the shape of the Harrier T Mark 10, seen here on its first flight. Unlike the US aircraft, which was intended solely for training and only had 2 underwing pylons, the RAF aircraft is fully combat capable and is equipped with FLIR. Meanwhile, the RAF is upgrading its GR Mark 7s to GR Mark 9 standard with a Pegasus Mark 107 engine and new avionics. The trainers are similarly being upgraded to T Mark 12 standard. The new Pegasus first flew in this aircraft, the first Harrier GR Mark 7A, offering improved reliability over the earlier engines.
次号はスウェーデンが独自に開発した戦闘機グリペン。ヨーロッパの新世代戦闘機の中で最も早く就役した機体です。小型かつ軽量でありながら、その一方で新世代の大型機に引けを取らない戦闘能力を誇るグリペンの高い能力の秘密を探ります。次号もぜひお買い求めください。